Hello friends, welcome you all to the Expert Solver YouTube channel. In this video, I'll explain the solutions for the problem of how to set up the communication in my software solution. The solutions will explain the viewpoint of synchronous and asynchronous communication. The importance of communication in human interactions and in the context of software engineering as well is explained in a previous video. Check the description for the link of it. Okay, let's move to the section of how to choose either synchronous or asynchronous communication in a solution. In order to do this, please pay some attention to some behaviors of your intended communication in your software solution. Check your software solution has following behaviors in a communication. Behavior set number 1. You need the expectation of the message to be delivered real time as the response for the message delivered. Expectation of your communication has to be received within couple of seconds to the sender. Rest of the program execution or business flow continuation depends on the response received from the communication. Therefore, no response or late response will pause your program or business flow execution. Program execution and the message response is like the baton pass in a relay race. Without the baton being passed properly, next runner cannot initiate his run. Okay, let's move to the behavior set number 2. You don't need the expectation of the message to be delivered real time or within couple of seconds. In other words, message sender fires the message and forgets the expectation of the message. Expectation of your communication can be delivered after minutes or hours. Rest of your program or business flow execution does not block until the message expectation is delivered. This is similar to an online food order you place to be delivered. After the order is placed, you focus on your other work without waiting till the food order is delivered. The recommendation is behavior set number 1 should be treated under the synchronous communication. The behavior set number 2 should be treated under asynchronous communication. HTTP is a common protocol that uses synchronous communication. HTTP REST endpoints are the common usage of synchronous communication. In asynchronous communication, there is a small part which is synchronous. Message acknowledgement is the synchronous part, while the expectation of the message is asynchronous. Long-running tasks can be fired using an asynchronous event. In the asynchronous communication, sender and the receiver are decoupled each other. In case of receiver is busy, offline or in a downtime, sender will not be impacted. This can easily bridge any load mismatches between the sender and receiver. Okay, let's move to the asynchronous communication in detail. Asynchronous communication can be in two types, that is event based and asynchronous endpoint based. In the event based scenarios, sender does not invoke a service or an API from the receiver. Sender just leave a message into a mechanism that the receiver is listening into. Messages are exchanged over message brokers. There are some queuing patterns in the usage of asynchronous communication, like competent workers pattern, and fan out pattern. Acknowledgement represents the successful event message published into the message broker or the queue. RabbitMQ, Kafka, and AWS SQS are the probable solutions to be act as message brokers or the message queues. Client raise the event, sending the message to the message broker and continues the client's remaining task. Once the receiver is ready to pick the message, it will pick it from the message broker and it will process it. In case of the receiver is busy or temporarily unavailable, message can remain until it will get picked. Okay, let's move into the asynchronous endpoint based communication. In this asynchronous endpoint based communication, there is a standard HTTP status code which is received to the message sender, that is HTTP 202. We call that accepted. So when the sender receives that HTTP response code, the sender know the message has been accepted by the receiver and he will process it and sender can continue his remaining tasks. Sender gets an update of the message that he delivered to the receiver from a separate call or from a callback which is triggered from the message receiver that he will send to the message sender's side. In asynchronous endpoints, sender's acknowledgement get delays until the request validation and queuing for processing happens only. That's a very small delay. Okay, let's discuss about the queuing patterns and the pub-sub pattern that are used in asynchronous communication. One common difference between the queuing patterns and the sub-pub pattern is in the queuing patterns, the message receiver pulls the message out of the queue. On the other hand, in pub-sub, the message on the other hand in pub-sub, message receiver receives the message from the pub-sub mechanism. It is not a message pull from the receiver's side. The pub-sub mechanism will push the message into the receiver. Okay, let's let's move to the first queuing pattern that is used in asynchronous communication. That is competent worker pattern. So in this competent worker pattern, you can see the client, message broker, and the message receiver. Client sends the message to the message broker, and the receiving service listen to the messages. Only one type of service or receiver type will listen to the messages. This is a scaling supporting queuing pattern. Therefore, this is suitable for microservices that can scale in and out based on the load. Multiple instances of the same receiver or the service compete to listen the messages. To respond the message and load spikes, receiving service and can scale in and out. This makes sure the redundancy of the receiving service since it allows multiple service instances. Therefore, a failure of an instance will not make an impact. A message will be picked by one instance of the service only. A successful message, a successful process of the message can remove the message from the queue by the instance that processed that message. Okay, let's move to the fan out pattern. This pattern is also quite similar to the competent workers pattern, but in this pattern, more than one message receiver type or a service exists. Uh, in this pattern also, client sends the message to the message broker. You may include the scaling feature for each services in the receiving side to improve the scalability and the redundancy as well. Okay. Okay. Let's wait for the next video to discuss about the pops up pattern. Okay. I would like to ask you a question from today's video. So we talked about the scenarios that we need to pick synchronous and asynchronous communication. So my question is, what will happen if an incorrect decision is made on selecting the communication type, either synchronous or asynchronous communication? So what will be your answer? Leave it in your leave it in the comment section. Okay, let's meet in the next video to discuss the next topic. Thank you.